All right, folks, so we decided that the first answer was what again? D? Okay, we put it in the Desmos, and we saw that everything was lower than that number, right? Okay. Second one, what are they asking you to do? Right here, solve the formula for A. Do you guys see where the A is? Solving for something means to isolate it. Good. So I'm going to go ahead and just rewrite this down here so I can work with it. If I need to isolate this, what do I need to get rid of, and what do I need to get rid of first? T squared needs to be gotten rid of. Agreed. How do I get rid of the T squared? What's happening between the A and the T squared? So what do you need to do? We need to divide by T squared. So those will cancel. And I now have S over T squared equals 1/2 A. Now what do I need to get rid of? The 1/2. Folks, what's happening between the 1/2 and the A? So what are you going to do? We're going to divide by 1/2. So those will cancel. Now, if I divide this, doesn't this look silly? A fraction and then another fraction? Okay, what is in front of this S right here? A 1. So really this is 1 divided by 1/2. Can you do that for me? What is 1 divided by 1/2? So it'd be 2S over T squared, and now I have my A isolated, which means my answer should be what? D. Now, ladies and gentlemen, after our first step of dividing by T squared, you probably could have figured out what your answer was, right? There's only one of them that has a T squared on the bottom, and it's letter D. Any questions for me here? Are you sure? Okay. Short set of notes for you today. Just reiterating these word problems. I'm going to try and let you do most of it on your own and just guide you through it, okay? How many days have we done on this stuff? Says right up top there, how many days? 6 days. It's a lot. Here we go. The Olympics were held in 1986 and have been held every 4 years except for 1916, 1940, and 1944. The winning height Y in men's pole vault at any number Olympiad X can be approximated by the equation. Does everybody see that equation? What's the highest power in that equation? 2, which means if the highest power is 2, what type of an equation is that? Remember that chart we filled in? Which one had a highest power of 2? Was it linear, exponential, or quadratic? This is a quadratic equation. If it's a quadratic equation, what shape should it be when it's graphed? It should be a parabola. By looking at the equation, should it be face up or face down? This should be face up. Isn't this positive? So it should look like this, shouldn't it? Okay. Complete the table to estimate the pole vault heights in each of the Olympic Games. Round your answers to the nearest tenth. Okay, so you got to fill in these boxes over here for height, correct? How am I going to do that? I don't even think I need Desmos. I don't need a graph. They're telling me the year, right? They're telling me what number Olympiad. So, for example, 1896 is the first Olympiad. 1900 is the second Olympiad. 1924 is the seventh Olympiad. Does everybody see that? So what do I need to do to fill in this side? I don't need Desmos, but I do need the equation. For the X, what is X? The number of Olympiad X. Everybody good here? And then figure out what it is. Now, guys, am I going to type in 1896 or am I going to type in 1? 1. Are we clear? Grab your calculators and you're going to plug in 1 to get this. You're going to plug in 2 to get this. And all the way down to number 26. Are we clear on that? Okay. So take a look at what I've got up here, folks. You understand where this comes from? Yes? Okay, so you need to do that for all, how many are there? 6 of them? Go. All right, so you should have typed this in 6 times. And I'm gathering that we need to review rounding, which is a little bit nerve-wracking for me. You guys should know how to round, right? You should. You ready for the first one? Okay, so William, what did you get for the first Olympiad? 130 point what? Okay, everybody grab your calculators. Grab your calculators, everybody. Type it in exactly like you see it, right here. Everybody got a number on their screen? I believe that number should be this. Is that correct? Tenths is 1 place past the decimal, which means I need to look at the 7. Anything higher than 5 or higher makes it go up. So what should my final answer here be, William? Perfect. 130.7. Everybody okay? So this means that in 1896 at the Olympics, the guy that won the pole vault vaulted 130.7 feet. I'm sorry, inches, not feet. That'd be huge. 130.7 inches. Are we good on that? Okay. What about in 1900? What do we have there, folks? Go ahead. How'd y'all do? How about the 7th Olympiad? Still doing well? The 10th Olympiad? The 15th? And the 26th? Okay. How we doing, guys? I have a follow-up question for you. My follow-up question for you is, how many feet is this? So if I want to take 487.9 inches, how do I turn into feet? Great. Can you do that for me? If you divide this by 12, that is approximately 40.58 feet. It's pretty tall. You all know what's up? Everybody okay? Now, if I was following my own directions, I would round this to 40.6. Right? Okay. Pretty tall. You guys all know what pole vaulting is, right? The little pole, and they hoist them up and over. Yep. Okay. Any questions here? Moving on. Okay. I think I want to go to the back next, to Christopher. Christopher is repairing the roof on a shed. He accidentally dropped a box of nails represented by the equation where f of x is the height of the nails after x seconds. So I'm going to draw you a cute little picture here. And you know how I feel about my pictures. I'm not a very good artist, right? House, good. He dropped a box of nails off the roof. If he drops it, it's going to go like this, isn't it? What does this look like? About a half of a parabola. So do you understand why the highest power up there is a 2? Because it will be a parabola. Will it be face up or face down? Look, it is face down because that 16 is negative. Good? It says, from what height did he drop the nails? Well, if I go ahead and I put this on a graph, like this is where he drops the nails from, correct? What is that? No, just in general, what is this point called? That's the y-intercept, isn't it? You see how it's on the y-axis? Go for it. Tell me what the y-intercept is. 14 what? feet. Okay, I want to go ahead and type it in for me. And I think I'm actually going to do this as well. All right, so we have y equals negative 16, right? X squared, was it plus 14? So how we doing, folks? We okay? And you all are getting that my y-intercept is right here? That happens to be the same as the what? The vertex and the y-intercept are the same point here. Okay, next question. How long does it take the nails to hit the ground? They hit the ground right here. 0.935 what? Great. Questions? No? Okay. Down to Della. Della's parents are throwing a Sweet 16 party for her. At 10 o'clock, a ball will slide down a pole and light up. Kind of, you guys all know what New Year's looks like, right? Okay. The function models the height of the ball after t seconds. Does everybody see the function? Now, folks, I want to reiterate some wordage to you here. A function is the same as an equation, is the same as a model. Does everybody understand that all three of those things mean the same thing? It's kind of like saying 0.5 and a half mean the same thing, correct? Okay, understand that all those words are synonymous. How tall is the pole? Type it in for me. Hold on one second. Let me get it up here. Negative plus 5 plus 25. How's everybody doing? We sure? Positive. Any questions on getting this on your graph? Okay, so how tall is the pole? Now, folks, if I were to draw this, the height of the ball, the top part is where it would start from, correct? So can you tell me how high the pole would be? Good. And what units are you going to put on that? Okay, I like it. How high will the ball be after 4 seconds? So there's two things you can do here. You can drag it until you get to 4 seconds. Right there? Y'all see that? I missed it. There it is. 29? 29 what? 29 feet. Correct. Or what else could you have done? Yeah, 4 seconds. Seconds is t, isn't it? So the t would be 4. So you could take that and you could plug in that 4. Can you guys do that and see if you actually get the same thing? We said it was 29. Let's see. Autumn says it is 29. And we said this was what, 30 something? Everybody okay? You see how you could have done that 2 ways, right? Questions for me here? Sure. Okay. Let's go back to the front. Teddy is building a rectangular deck shown. Write an equation representing the area of the deck. Guys, it's a rectangle. How do I find the area of a rectangle? Length times the height. What's the length? X plus 6 times what's the height? How's everybody doing here? Do you see how they want the area of the deck y? So this will be y equals that. Everybody doing okay? What am I going to do with this? Split it in half and distribute. So what will it look like when I split it in half? Okay, distribute. What is x times x? X times so if you put everything together, it's x squared. What do I get here, folks? Positive 4x. Good. Ladies and gentlemen, how are we doing? Doing okay? So tell me, what's the highest power on this equation? Which means what type of equation is it? Quadratic, which means what shape should it be? A parabola. What is the equation of the axis of symmetry? Now, there's two things you can do here. You can either put it in Desmos, and then you can tell me what the axis of symmetry is, or we can calculate it. Which one would you like to do? Go for it. X squared plus 4x minus 12. Was it plus 12 or minus 12? How we doing? Good? Now, the axis of symmetry cuts it right down the middle, correct? If we cut it right down the middle, doesn't it have to go through that point? Yes, and if it goes right through that point, it would look like that. Agreed? What do these axis of symmetry equations always start with? X equals, what does the x equal here? 2. So my answer for the axis of symmetry will be, if I calculated it, folks, all I'd be doing is finding the vertex, which this is in standard form, right? So you'd use negative b over 2a. Questions? No? I want to show you that that would actually work out the same way. This is ax squared plus bx plus c, right? What's the negative b? Over 2 times. So this would be, uh-oh. Something happened, though.
It's because you put it in as negative and it's plus 4x. Yeah, but it flipped.
We gotta flip it. Did I type something in Desmos wrong?
Yeah, because you put that in Desmos to negative 4.
Oh, this should be a pot. How come you didn't stop me? I did not know it. So the axis of symmetry really is right here. So it should be negative 2. All right, well, we can fix that. Negative 2. Okay, now if I would have divided this, folks, what would it have given me? Okay. Good. Now it says, what is the maximum amount of space the deck can cover? I have a problem with this question. You tell me what the problem with this question is. You guys gotta speak up, remember? Why can't I solve it? This thing isn't even a max, is it? No, this thing is a min, which we would know right away from our equation, right? Yeah, so I don't really have a max. I can make that deck as big as I want as long as I got enough space. Is that okay? What's that? Yeah. So, this question, you cannot answer. It is not a maximum. It's a minimum. I just wanted to make you think. No. But you should understand why this doesn't quite make sense, right? Okay. Any other questions for me? No? Okay, so for your homework tonight, you're going to have a worksheet, and it's all word problems. Please use Desmos to help you find your maxes, your mins, your starting points, your x-intercepts. Good? Okay.